Okay, so a couple announcements and logistical things. So as you guys should know, with the problem set's due at the start of class. If people turned in later than that, I will take points off. Tessa's going to go over the problem set in section today. So there really is a hard deadline as of 3 p.m. If you turned in to me later than 3 p.m., I'm not going to give you any credit. So if anybody hasn't turned it in, do know that. Let's see, a couple comments about Unit 4, which is that I'm going to basically hit a few highlights in the first few sections and not go over it comprehensively in class. But you are expected to know basically all the material that's in the unit. I will be talking through section 5, which is on functions and scoping and frames in quite a bit of detail, and I'll be talking through section 8, which is on manipulating text and regular expressions in quite a bit of detail. And the other sections, I'll be hitting highlights here and there, just so you know sort of what the plan is for this unit. A lot of the material in the other sections is stuff that was in the boot camp, and that I've already said I expected you to have some familiarity with coming in, or that you would need to do some self-study. I have a question to run by you guys about the end of the term. So I've already gotten a few queries about scheduling of the project and when that would be done, and I haven't sort of fully worked out exactly what the scope or exactly the logistics of the project, but I did want to get a little bit of feedback from you guys. So the last day of class, if I'm getting it correctly, is December 6th, which is a Friday, and then reading, I don't know if there's 3 R's in there, reading whatever, relaxation and something week, ends December 13th, and then I think the last exam day is December 20th, which is getting pretty close to the holidays. And our official exam date is December 19th, but there is no exam in this class. Okay, so this is a little bit long-winded. One possibility for the project is to have it due, say, the end of the reading RR and R week, and another possibility is to have it due essentially right around the time when the final exam is. So I guess I've just asked for a show of hands if there's a preference for having it due later, in which case you have more time, versus later, in which case it might be harder for you to leave town and do whatever it is you want to do during the holidays. So how many folks would prefer to have the final project due something like December 13th? Raise your hands a little higher. Okay, and how many folks would prefer to have it due later, something like December 19th or so? Okay, so it seems like the majority, maybe 2/3, 1/3, wants to do it earlier. So I will take that under advisement. I won't promise that I'll follow your suggestion, your request, but I will take that. I will consider that when I'm trying to work things out. And I'll try and figure this out fairly soon, so I can let you guys know who are trying to make travel plans. Okay, so any questions from last time, or any other things that have come up? Okay, so as I said, section today we'll be talking through some of the solutions for the problem set. The idea of doing that in section fairly soon after you guys submitting the problem set is to avoid having that kind of thing that happens often in classes where there's a 2 or 3 week lag before you get back the graded problem set. And then it's no longer fresh in your memory, and so it is no longer quite as salient in terms of seeing how other people did it, seeing what the solutions look like, and learning from that based on relative to what you had done. Okay, so let me pick up with section 4, again, just sort of hitting some highlights. I want to mention another thing that ties together writing R code and some of the scripting and interacting with the operating system that we've done, which is that, I think I mentioned this at one point, but probably may not have highlighted it as much as I should. If you're writing bash code and putting it in a file that you then want to be able to execute, in general you want to put the following syntax as the first line of your file. So you do this, and then you have all your shell code in the file. And the reason for that is this identifies to the operating system that the shell that it should use to execute this code is actually the bash shell. If you're on a system where that's the default, you may not need this, but if you take your code and then try to run it somewhere else where the shell that's set up, the default shell is something else, your code would presumably not run correctly because it would be trying to interpret it with a different shell. So there's some nice functionality in R that actually allows you to do something similar. It's actually a sort of functionality in R combined with how Unix is set up, which is that if you write a file of R code, and the first line of that file is syntax that looks like that over there, but is specific to R, in particular calls this executable R script, which is basically the underlying R engine for executing R code, then you can basically run a file of R code like this, just as you would have run a file of shell code from the command line in Unix. So all you need to do is write your file of R code, put this in as the first line, make sure the R code file is executable, and then you can run it like this. So that's kind of a nice trick to be able to make a little R script that will do something. You can just run it from the command line without having to open up R or without having to do R command batch and that sort of thing. So I just wanted to make you guys aware of that. And there is a way to pass arguments in from the shell into R and then have R be able to read in and interpret those arguments. And it basically involves this syntax here. By default, each of the arguments is going to be treated as a character string. And so if you want to treat them as numeric or as logical, you need to do you need to cast the variable into the other type of variable. So I won't go over that in any more details, but you can see that in the notes if that's something you want to try and do. Okay, any questions about that? Okay, let me hit a few highlights in terms of R packages. So by now all of you should know that there's a sort of thousands of add-on packages available on the Comprehensive R Archive Network website. One nice trick that you can do, so of course you can load a package in with the library function. You can also use require. But one nice trick is that you can see all of the packages that are available to you by just typing library. And this is how it shows up in RStudio. It would show up somewhere differently if you're just using R from the command line. But this basically shows all of the different packages that are installed on your machine. And it actually shows you where on the file system they're actually installed. So there are a bunch of ones that are installed on my machine here in my home directory, users Pechoric. And then there are some others that are installed in a sort of system level directory that are more sort of core packages that are in general oftentimes installed with R by default. So that gives you some sense of what's installed, and then of course if you need to install something from the website, then you can do that with install.packages. Another thing that's nice to do is sometimes you don't have a very good sense of, somebody says, hey, this package is kind of useful, and you don't have a good sense of, how is it useful, or what are all the various things that it can do. So oftentimes on the website there's a thing called a vignette, which will be sort of a textual description with demo, sometimes with demo code and whatnot, that describes what the package does overall. Not quite as helpful as that, but oftentimes there is not a vignette, and so sometimes this is your best bet, is to do something like this, where you say library, and then you pass it the argument help equals, and then the name of the package that you're interested in. I'm having a little trouble with hand-eye coordination here. So if I do that, what it'll do is it'll basically print out a whole bunch of information about the package, who developed it, a description from the README file, that's the sort of overall meta information file for the package, and also list out all the various functions and a very short description of what those functions are. So this is sometimes helpful for just getting an overall sense of what's the kind of functionality that's available in a package. Okay, let me see what else I want to say here. This was sort of already hinted at in what I showed you when I just did library with no arguments and showed you that some packages were installed at different places on the file system. So if you want to know the different places that R is looking for packages when it tries to load them, if you do library in the name of the package, if you do this .libpas argument function, this will show you the various places on your particular system where it's looking for packages. So some of these might be in your home directory. For example, it looks like I ran this on my SCF machine. So this is my home directory on the SCF. Some of them will be more system-level directories. Sometimes there's more than one of those. And if you do search paths, it will actually show you for specific packages, for example, here's fields, here's maps, here's stem. It'll show you the explicit directory in the system where that particular package is being loaded in from. So that can sometimes be helpful, so you know, is it loading in, if you load in a package, is it loading it in from your personal home directory, maybe you've got installed there, or it's possible it might be loading it in from the system directory, and there could be sort of versioning issues. So this is sometimes helpful for sorting that sort of thing out. And if you do need to install a package yourself that's not already available, then you can do things like using install packages, and you can tell it explicitly where on the file system to install a package. So that's helpful if you don't have administrative privileges for the particular machine that you're working on. And you can also install a package from a zipped up file instead of installing. So this would install it from the web. You can actually download the zipped up file and install it from that file as well. So I think that's all I want to say about packages for now. We'll come back to some of this issue of the namespace of packages and what the objects are that are stored in association with individual packages. We'll come back to that a little bit later. Any questions about packages? Okay. So the next thing I want to do is talk a little bit about assignment and just a couple occasionally tricky things with that. Yeah, so let me switch over to our studio. So this is just the demo file that's in the Git repository that goes along with the PDF. Okay, so I just want to point out what happens when R is doing an assignment. So it's okay to do this with an equal sign. Do people in the back want me to make this bigger? No, not hearing too many complaints. Okay. So this is fine to use an equal sign instead of the assignment operator with the less than and the minus sign. If you do it in that context, it doesn't work in this kind of context. So that will give us an error. So it says unused argument. And the problem is that when you are doing this within another function call, the main use of equals is to associate the name of an argument with the value that's being passed in as that argument. It's being passed in for it to be that argument. And so when the system.time function, which is used for timing code, sees this, what it says is, oh, you're passing in an argument named out with this value. But system.time isn't expecting an argument named out. I mean, maybe you might get lucky and you might pass in something that, lucky or unlucky, as the case may be, and pass in something the correct, an argument name that is one of the arguments that that function is expecting. But in general, you won't be, and so this is not going to work. On the other hand, in this case, this would work because here, system.time is expecting you to pass in an expression that it can then run and then time it. And so this is the standard way that you would pass in an actual R statement or expression. So this does indeed work. Okay, just to highlight that a little bit more and see a little bit more about what happens when we do. Now we're going to sort of flip this around and say what happens if we're using either equals or the assignment operator as an argument to a function. So if we look at the mean function, we can see that it's expecting an argument named x and then potentially some additional arguments that are unspecified. So if I do this, then this is the standard way you'd specify an argument in R. You'd say, okay, I'm going to pass in 3 and 7, that vector, as the x argument to mean. Mean is expecting an argument named x, so that should work fine. And that's the standard. That would be the standard thing to do. We don't have to say x equals, because we could just pass in the actual object, and R will know that we'll just match by position as opposed to by name. But if we do this, that's allowable. It'll run. Okay, but it's not quite doing what we would expect, which is that what it's doing is it sees this, sees that that's an assignment, so it actually goes ahead and before it runs the mean function, it actually assigns 3 and 7 to the value x, and then it treats the result of that, which is the value that got assigned, as the input to the mean function. So as a result, the result of this should be that the x equals 0 is actually overwritten in your workspace. So if we just type in x here, you can see it's now 3 and 7 instead of 0. So in some sense, this executed and did what you wanted it to do, which is it took the mean of the values 3 and 7. But in another sense, it had the side effect of replacing the original values of x, the original x, which is sitting there in your workspace. So that might very well then, be a bug that later on down in your code would cause a problem, because you've overwritten x and maybe you weren't really aware that you overwrote it. Any questions about what's going on there? If we now were to do this, is that going to work? Yeah. Okay. What do you think is going to happen? Okay. So the question is, is mean expecting an argument named y? We've looked at it, and it isn't, and so unless something funky is going on with the ... as it's off the screen here, that's not an argument name that mean is expecting, so that should give an error. So yeah, it says x, the first argument x is missing, there's no default for it, I can't proceed and do anything because I need a value for x to be able to take the mean of. On the other hand, this would work. This will assign 3 and 7 to y first in the global environment, and then the result of that would get passed into the mean function. It's not saying its name is y, it's just going to pass in the 3 and the 7. So that will work. It should give us 5, and we should also see that there's been this side effect of assigning to y 3 and 7. All right, any lingering questions there? Okay, I want to skip it. The other thing, I just want to point this out as something folks might not be aware of. Sometimes it's a little tricky to know whether R is treating things as decimal values or integers. So in general, R often defaults to treating everything as a decimal value, even if it looks like it's an integer. So for example, if you do this, and then you do type of, to find out the underlying type, we'll talk a little bit more about that in a second. It'll say it's a double, so that means it's a decimal number. We'll talk about why it's called a double in a few weeks. And on the other hand, if we do this, it says I can use class too. We're going to talk about that distinction in a minute. It says that's an integer if I use the double colon operator. So depending on exactly what function gets used, sometimes it will be doing things behind the scenes that are not all that obvious in terms of whether it's treating it as a decimal number or integers. We can force it to treat them as integers by tacking on this capital L here, which is sort of a vestige. I think that stands for long integer, which has to do with sort of the roots of programming and the development of R. But in any event, that syntax will force R to be treating the values as an integer as opposed to a decimal value. And then I just want to hit this. This is something you guys should have seen before. I talked about in the boot camp a fair amount, which is this idea that you can coerce. Yeah, there's a question.
Is there a difference between typo and class?
Yeah, I think I'm going to get to that in a second. That's why there's this comment here. So no worries. But yeah, I'm jumbling my order here a little, so apologies for that. So we can coerce things from one kind of object to another with the functions that are in this as family, and that's fine. That's useful to be able to do. One of the tricky things about R is that sometimes it will do that coercion behind the scenes and not tell you or warn you that it's going And sometimes that's fine, and it makes your coding life easier, but sometimes it'll be doing things that you weren't quite aware of and could cause problems. So as an example of R doing things behind the scenes, here I'm going to create a vector of floating decimal numbers, just a random set of 5 random values. And now we can ask the question, well, what if I try and assign into that vector the value hat? So what are the possible things that could happen if we are doing this assignment? We'll try to do this assignment. So think about your think about if you're creating R and you knew somebody might do this. What are the possible reactions that you could code up that you could create the language to have in this case? Yeah, please. Okay, so it could treat this as a string, but let's push that a little bit further. If the rest of these are numbers, all the values in a vector have to be the same kind of value. So if it turns the third one into a string, it could turn all of these into strings behind the scenes. So that's one possibility. What else could it do?
Could stop here, maybe.
Could what?
It could stop when it comes up.
Yeah, it could just give you an error back, right? Another sort of variant on the idea of turning it all into strings is it could do that, but it could warn you that it's doing it and say, hey, coercing or casting everything to character type or something like that. It could say something like that. So there were some, there are choices that are made when you're developing a language, and this is one of those kinds of choices. And if we look and see what it actually does, it doesn't give a warning message or an error message, so it actually runs. And then if we type X just to see what things look like, it does indeed look like it turned everything into a character. It turned it into a character vector. It turned all of these into character strings. As you can see with the quotes around everything. So you could decide for yourself whether that's what you would have done if you were developing a language, and whether or not you think this is reasonable behavior or not. Those are the choices that the R developers made, and there are lots of situations that'll come up that we'll see where the developers had to make some choices like this. Okay, so let's go back to the PDF. Actually, what was your name? You asked the type versus class question. Brad. So Brad asked, what's the difference between class and type? I'm a little confused about where I am in my own notes here. Sorry about that. Okay, so basically, when you do type of, what it's going to tell you is sort of the very fundamental underlying type of object that this is in R. And that sort of goes back to how R is storing things. R is written in C, so basically how R is storing things as objects in C. So the types are sort of the fundamental different kinds of objects. And then classes are basically built on top of and extend the types. So if you're talking about fairly simple kinds of objects, the type and the class are often very closely related. But once you get into more complicated objects like the output of the linear regression model or things like that, then you start to have classes that sort of get somewhat divorced from the types. So we can, if we look at, this is from the Adler book that's mentioned in the syllabus and is a good reference if you want to, if you're looking for something to supplement the notes. But this will basically, oops, I managed to lose the page. That was a little awkward. Let's see, does this... I'm not sure why it's not letting me why it's giving me this bit about the account. Let's see if this works. All right, it still doesn't like this, even though I should be in the Berkeley network. All right, so all right, apparently I'm not going to solve this within the time that is reasonable here. Okay, so if you did this on your own, what you should see is a table that shows the various kinds of R objects. And the basic ones are basically different kinds of vectors, like regular vectors that we're used to, like decimal vectors that are called numerics in R, integer vectors, Boolean vectors, character vectors, and lists. And then there are a couple other more complicated kinds of fundamental objects. But a lot of what R does is based around vectors. And you can think of lists as being vectors, but just vectors of sort of heterogeneous pieces that are connected together. So those, when you do type of, you're going to generally get back something like those different things that I just mentioned. So, for example, if we create a data frame, and then we say, what's the type of the data frame? It says it's a list. So the list is one of these fundamental types in R. But then basically, if we ask what its class is, that gives us, that's sort of at this higher level of thinking about objects in R. It says, oh, you know, that's actually a data frame. And if we create a matrix and ask what its type is, well, it says it's integer, which is basically just a kind of vector. If we made a matrix of decimal values, it would have said either numeric or double. I forget which. But this is also indicating that it's a vector, because anything that's integer or character or numeric is a vector as well. Okay, in some sense it's a vector, but this particular function is telling me it's not, because it's classified as a matrix. But we can also ask what class it is, and then it says that it's a matrix. So basically, if you want to know sort of at the sort of a higher level of how R is treating different objects, you would use the class function, and that's going to return back things like matrix, and it'll return back LM if you have the result of fitting a regression. It'll return back data frame, things like that. If you do type of, it's going to show you sort of more fundamentally what's the underlying structure upon which the object is built. And that's why in this case it's telling you integer, and in the case of the data frame it was telling you a list. And I believe if we'd done a regression and we had said what's the type of the regression output, it probably would have said list as well as instead of an LM object. Whereas if we'd done class, it would have said that it's an LM object. Yeah, Hobart?
Remind me what mode is.
What? Mode? I'm not sure what mode does. What does it return in this case? That's interesting. So it seems like it's not distinguishing between integer and numeric. Yeah, I don't remember exactly what mode does. Okay, so that gives us some idea of the distinction between class and type. This is actually sort of in the wrong place in the document. Okay, so I want to do a little demo of, well, more of sort of have you guys think through what happens here with coercion of objects, just to hit home on this point a little bit more. So what I'd like you to do is look at this code here, and there are basically 3 different attempts to use apply on a data frame here. And what I'd like you to do is try and figure out what you think are the steps that are going on behind the scenes and why the results of doing these operations is what they are. So I'm just going to create a data frame here. It's going to have 5 rows and 3 columns. Okay, and then I'm going to do an apply. That's not going to work. I'm going to do another apply where I subset first to just the second and third columns, and that is going to work. And then I'm going to do another apply where I create the data frame a little bit differently with cbind, and that's not going to work. So what I'd like you to do is take a minute, stare at this, think about it, discuss it with your neighbor, and try and think about what's going on and why this is producing the behavior that it does, and what the different steps are that R is going through, and what different coercion from one class to another might be going on here. right, so when we create this data frame, the first column is a character vector. Right? Second column is a vector of decimal numbers, same as the third column. So what do you think is happening when we try and apply this function by row? What has to happen as it works with that first row, for example? Okay, so yeah, so it's trying to do a plus with the function, but let's first think of that. So we're getting there. Let's first think about what actually happens when it pulls out that row. So it's trying to pull out the whole row, and what are the elements in that row? Raise your voice. Well, so but what are the different elements? What are the first, second, and third elements in that row? A character, a number, and a number, right? Okay, so now think about, it's trying to pass that row into whatever that function is that's not named, right? Well, all of a sudden, what is it faced with? It's faced with, it's got a character, a number, and a number, which can't be treated as, you know, which are just different kinds of objects. So presumably, this idea that it's non-numeric, presumably what's happening is it's coercing everything to be a character, like we saw with the R norm 5 and the hat example. And then all of a sudden it sees, okay, it sees A, quote, whatever the number is, quote, whatever the number is, it tries to add together two characters, and it fails. Right? So that becomes this error message. So why, presumably, does this work? Well, now we've only pulled out the second and third columns. Those are all numeric. And now if it's now trying to work with a row of that, it can keep those as numeric values, and those just get passed in to the next, to the plus function here, the plus operator. So what do you think is the distinction here? What do you think is going on there? Yeah.
Is the data frame
Oh, I see. That's interesting. I mean, we could, yeah. Let's look and see what DF2 looks like. That's just sort of going to give away the answer, I guess, but that's fine. Well, so suppose it actually does create a data frame. What do you think is actually happening as the first step here? If you're the R interpreter going in and trying to interpret this code, what do you do first? Say it again. Okay, so first off, if we go from the inside out, it creates the character vector, it creates the numeric vector, it creates the numeric vector. Then it tries to do a C bind. And that is actually going to create all characters because it's trying to create a matrix. And the matrix has to have all of objects all of the same kind in it. So by virtue of having thought that maybe the person's who's writing this code doesn't realize you can just do this and pass in the actual columns explicitly. They think, oh, we need to sort of glom everything together and then make it a data frame. But in the context, in the process of glomming everything together by using cbind, it tried to make a matrix out of it. It made everything characters. Now the data frame is, let's go and answer Tom's question about whether it actually made a 3-column data frame or not. So it does indeed look like it made a data frame. It's not actually showing quotes here, but so let's actually do type of df2x1. Wow. That was unexpected. That can't be true. Okay. Oh, interesting. Okay. So, can anybody see from what I've done so far what it seems like it's doing? Yeah, Kaushik?
I guess it's converting the first column into a factor.
Yeah, it looks like it's making a factor, because whenever we see levels here, that indicates it's treating something as a factor variable. That doesn't quite explain what's going on here. Because we pulled out the column, and then somehow maybe there's a coercion going on that it was a factor, and somehow in pulling it out, it's now thinking that it's now converting it to a set of integers, although it's not at all clear to me why. It's
Just
really
because two of the columns is numeric and only one is character, so it's like by majority of four.
well. I think they're all being treated as either factors or characters. I mean, let's look at df1, 2. Oh, it's interesting. That's treating it as numeric. Yeah.
If you do plus df2 $x2, so the column,
Yep.
then that's actually a factor.
Oh, that was, sorry, I did this wrong even. That's, here we go. Oh, okay, so, yeah, or that, yeah, either way, thanks. Okay, so it does look like it's treating things as factors. It's not totally clear to me why it's not doing that when I pull it out as a, that's interesting. Wait a minute, isn't that what I just did? Oh, I did type of. So maybe what happened, so it looks like class is giving me a consistent answer with the other things that we're seeing here. Oh, okay, now I see what's going on. Does anybody else see what I just realized? So this goes back to the difference between class and type. So if we think about a factor, when we did class of these columns, it said, oh, it's a factor. It's these things that have different levels. We use these to work with categorical variables, right? But now if we think fundamentally of how R is storing a factor variable, I think what this is indicating when it said that the type of that was integer, is it's saying underlying this, how it stores a factor variable is it just stores this as integer with some labels associated with each of the different integer values. And so that's why it's saying that the type of that column is integer, even though it doesn't really have numbers in them. It just has numbers that are really just being treated as labels. So I think that explains the mystery in my debugging from a few minutes ago. Okay, so that was actually sort of an enlightening and interesting example, even beyond what I thought it was going to be. Any questions or comments about that? Okay. Sorry, I'm here. All right, I'm gonna skip around a little bit. I'm gonna skip over a bunch of stuff. I want to just point out one quick thing about character strings and quotes, which is, we've already sort of seen this in the context of the bash shell. So if we want to work with character strings in R, we can do things like this. We can use single quotes within double quotes, and that'll work. We can use double quotes within single quotes, and that will work. We just need to make sure we're sort of beginning and ending, and then we can do different stuff with the same character, and we can do different stuff with different quotes in between. We can also use escaping with the backslash, which I think we've already seen to some degree in some of the Unix contexts. That if we really want to have a quote embedded within a string that's delimited by double quotes, we can do a backslash to tell R, oh, don't treat this as the end of the string, treat this as part of the actual string. And that should all work fine. Oh, the other thing, let's see. I think I may have mentioned this before, when we're working with the bash shell, usually what happens with double versus single quotes is if you have double quotes and you put a $sign and then the name of the variable, is it will actually fill in the variable name. Whereas with single quotes, it won't actually evaluate what the variable is and it won't fill it in. So that's one of the distinctions in the shell. And the other thing I want to point out that I think I mentioned in one of the Piazza posts is if you're cutting and pasting from a PDF, you'll often be cutting and pasting in curly quotes into your R code instead of the straight up and down quotes, and that's going to give back an error. So oftentimes there'll be an error if you're cutting and pasting from some file format, R code from some file format, and trying to paste it directly into the R console or paste it into a script file and then evaluate that code. So that's one thing to check whenever you're doing the cutting and pasting, is making sure that those are actually these straight up and down quotes, and those are the only. These are the straight up and down ones are the ASCII characters, and those are the ones that R knows how to interpret when it's working with these things. Okay. Skipping ahead a little bit more, I want to mention this idea that lists are actually fundamentally also treated as vectors in R. So if I want to extract pieces from a list, people should be quite familiar with using the double bracket to extract from a list, and that's just going to pull out whichever element of the list you indicate. So if you have some list X and you do double bracket 7, it's going to pull out whatever the 7th element is. But you can also think of a list as just being a vector where each of the elements of the vector is essentially an arbitrary object. And in that case, you can use single brackets, and I could pull out x, c1, 3, 7, for example. And that's going to give me back another list that only contains the first, third, and 7 elements from the list x. So that will work fine, and as a result, x of 7 will also work, but it's going to give me back something that is actually a list. It's just a one-element list. Whereas this would give me back whatever the piece of the list was, and it isn't necessarily going to be a list anymore. If the 7th element of the list is just the number 3, it'll just give me back the number 3, and it won't be a list anymore. But if I do it like this, it'll give me back the number 3 as in the form of a list. So that's sometimes useful to know. The other thing I want to point out here is this trick that I actually also showed in the boot camp, so a number of you may have seen this before, which is that operators are also just functions, so plus, brackets, things like that can also be considered to just be functions. And so you can do tricks with operators like this, where suppose I'd set up this list of parameters where each element of the list is a mean standard deviation pair. So often, if you're doing sort of stratified analyses or something like this, you might end up with an object that looks like this. It's a list of lists. And you might want to pull out the mean element from each of the components of that list. I want to get back the 7, and then the 6, and then the 2. I just want to strip out that information and get it back in a handy format. So you could write a for loop or something like that to do this, but you can actually do this in one line with an L apply or an S apply by recognizing that this double bracket operator can just be treated as a function. So S apply applied to params is sequentially going to pull out each of these lists. And if I think of pulling out that first list, I'm going to have something that's just a list with mean equals 7 and SD equals 3. And now if I think of applying the double bracket operator to this, if this were, say, something called z, I could do z double bracket 1, and that would pull out the 7, right? But I could also write this code as the double bracket function applied to the object z with an additional argument 1 telling it to pull out the first element here. And so by doing sapply with the double bracket and then the 1 as the next argument, that's basically just marching through each of these pieces, that one, the A, the B, and the C, and doing this sequentially to them. So it's going to pull out first the 7, then it's going to pull out the 6 from the mean from the second one, then it's going to pull out the 2. So that's a nice thing to recognize when you're working with lists and thinking about operators. Okay, any questions about that? Okay, I have a bunch of stuff in here about doing stratified stuff. That was all in the boot camp. You guys all should have seen that before. I think I'll see here. Let me show you this one last thing before we break here. So let's consider this list. So I just have a list that contains 3 different 3-long vectors. And if I look at rbind, I can see that the arguments of rbind are ... So rbind is expecting me to pass in the first row, the second row, the third row, the fourth row, all separated by commas, so that it can then rbind them together to make a matrix. So I could do something like rbind my list of A, my list of B, my list of C, and that'll work fine. It'll just rbind them all together in the form of a matrix. The problem is that that's sort of clunky. And what if that my list object had many objects that I all wanted to rbind together? Okay, I wouldn't want to have to write them all out like this. So if I actually just tried to do rbind of my list, that's going to do something funky. it's going to give me back this result here, which doesn't seem like it works. So we'll come back to that in a second, but I do want to show you the shortcut here to actually be able to do this, which is do.call is a nice trick that you can use where it will take a function that's expecting the dot 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 argument, so an argument, comma, another argument, comma, another argument, and it'll basically be able to use a list in place of that dot 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 argument. So it's basically going to take the elements of my list and try and R-bind them together. And in this case, that will work just fine. And so that would work regardless of how many elements there were in my list. But let's just see this for a second, and I'll leave you with this as a little homework assignment to think about for class on Wednesday, for us to discuss in class on Wednesday morning. If I can get to where I am here. I guess I should just search. Okay, here we are. So that your task for, to think about over the next couple days is think about why did it do this, and similarly you could, if you do that, you can see it creates this result. So try and figure out what exactly it's doing and what this object that it's created is made up of. What are the pieces of this object, and why? What it's done actually makes some sense if you think about it from the logic of how R tries to manipulate objects. So see if you can figure out what's going on in that case, and we'll talk about it on Wednesday morning.